Hello, pre-calc. All right, I said I'd put up the answers, and I am, but I wanted a lot of space so that you could see my work. So, this page is half of 7.3. I've done it both. I've done number 1 both in radians and degrees. Either one is fine. You should get the same answer. Number 2, remember that you don't have to use these same values. You could use something else, or you could have added, and that you could be doing sine of 195 instead. You should still come out with the same answer. These are the same, I just changed the order. So square root of 6 minus square root of 2 over 4. Square root of 2 minus square root of 6 over 4. Square root of 2 plus square root of 6 over 4. Number 4, you don't have to worry about it, but what you would do is find sine of 915, which is square root of 2 minus square root of 6 over 4, and flip it over, but that won't be on the quiz. Number 5, again, I did it in radians and degrees. Negative square root of 2 minus square root of 6 over 4. Number 6, you would find cosine of pi over 12, and when you get the answer, square root of 2 plus square root of 6 over 4, flip it over. On the bottom of that page, same deal, you're still using the cosine sum formula, cosine x, cosine y minus sine x, sine y. You've got sine x and y, you need cosine x and y. You draw a triangle. They tell you it's in quadrant 1, so you don't have to worry about negatives. Find the missing side, find cosine of both, and then just plug in. So cosine x times cosine y minus sine x times sine y. And then you just simplify, you get 16 over 65. For number 8, formula is sine x cosine y minus cosine x sine y. Same deal. Draw the triangles, you're in tangent 1, everything is positive. Sorry, quadrant 1. Tangent 1 would be weird. Sine x cosine y minus cosine x sine y. Simplify, 13 over 85. Number 9, they're giving you cosecant and cotangent, but that's fine. Cosecant is hypotenuse over opposite. Cotangent is adjacent over opposite. Fill them in, find the missing sides, and then get both sine and cosine for x and y. Then use the formula sine x cosine y, cosine x sine y, negative 16 over 65. For the identities, what you're doing is simply plugging this into the formula, cosine 180 cosine theta plus sine 180 sine theta. You don't know what this is, but you do know what this is. So negative 1 times cosine theta plus 0 times sine theta. 0 times anything is 0. That's all you're left with. That's what you wanted. Same thing here. Plug into the formula. That one's 0, that one's 1, so that's all you're left with. 7.4 page. Okay, this one again, they're giving you one value where you need both of them. This time, the quadrants are not all 1, so I want to be clear about this. So we need to find sine 2 theta and cosine 2 theta. Sine 2 theta, the formula is 2 sine theta cosine theta. So we've got to find cosine. We're in quadrant 1, so we actually don't need to worry about negatives. Draw the triangle, find the missing side, find cosine, plug into the formula, 120 over 169. For cosine 2 theta, for all of these I'm going to use the cosine squared minus sine squared, but if you use another formula you should get the same thing. So plug in the cosine you already found, plug in the sine you already found. Work it out, simplify, negative 119 over 169. Number 5 is in quadrant 3. In quadrant 3, both, the hypotenuse is always positive, but both the other sides are negative. So tangent is 1 over 2 because the negatives cancel out, but when you fill them in, because you're in quadrant 3, these sides have to be negative 1 and negative 2. So cosine is negative 1 over square root 5. Sine is negative 1 over square root 5. Cosine is negative 2 over square root 5. Plug into the formula, simplify. Plug into the formula, simplify. 4/5, 3/5. This one is in quadrant 2. So in quadrant 2, your adjacent side is going to be negative, your opposite will be positive. Negative 5 halves, secant gives you hypotenuse over adjacent. Fill in the missing side, plug in. Your sine 2 theta is negative 4 square root 21 over 5. Your cosine 2 theta is negative 17 over 25. And no, a decimal will not be acceptable for this. I want the simplified radical. Number 7, back in quadrant 1, everything is very simple. Find it, fill it in. sine 2 theta is 24 over 25, cosine 2 theta is 7 over 25. Proofs. Oops, sorry. Sine 2x, replace that using the formula. This side becomes 1 plus 2 sine x cosine x. Over here, you FOIL this out, multiply by itself. Sine squared plus cosine squared adds up to 1. Sine x cosine x plus sine x cosine x is 2 sine x cosine x. These are the same. You're done. This one, replace sine 2x with 2 sine x cosine x. Cancel out the 2. You're done. Last page. All right. Principal values. For sine and tangent, that's negative 90 to 90. For cosine, that's 0 to 180. If you want to replace cosine with a variable, totally fine. Subtract from both sides, divide by negative 2, cosine x is equal to 1. Look on the unit circle, it's 0. This one, add 1, divide by 2, take the square root. Remember, when you do this, you've got to say plus or minus, because it could be either one. Square root of 1/2 is the square root of 2 over 2. Sine of x is positive square root of 2 over 2 at 45 degrees. It's negative square root of 2 over 2 at negative 45 degrees. Number 3, you need to replace secant squared with 1 plus tangent squared. It's one of the Pythagorean identities you're supposed to know. 1 plus negative 1 is 0. Factor out the tangent. Tangent is 0 at 0 and 180. Tangent is negative 1 at, at not there. My apologies. Tangent is negative 1. Let me just notice that. Tangent is negative 1 at 135 degrees and 315 degrees. Sorry, the values I used were where it's positive 1, but it needs to be negative 1. So 135 and 315. Number 4, you want to replace cosine 2x, but you still want it only to have cosine, so you're going to use this formula for cosine 2x. Group them. You got to factor that. This gives you cosine x plus 2 times 2 cosine x minus 1. Cosine x can never be negative 2, so that doesn't give us an answer. Cosine of x is 1/2 at 60 degrees and 300 degrees. Factor it. You get 2 sine x minus 1 times 2 sine x minus 1. Those are the same thing. So sine of x equals 1/2. That happens at pi over 6 and 5 pi over 6. Once again, replace cosine 2x, but this time we want sine, so we use the one that's 1 minus 2 sine squared. Group them. 1 plus negative 1 is 0. Factor out the sine. Sine of x is 0, which happens at 0 and pi. Or, by the way, what I did here was I subtracted 1 divided by negative 2. So sine of x equals positive 1/2 at pi over 6 and 5 pi over 6. All real values. This one took a while. Sorry about this. You need to replace cosine of 2x. You need to use only cosine. So you use 2 cosine squared x minus 1. Then you got to multiply this whole thing by 3. So 6 cosine squared x minus 3. Then go ahead and combine the minus 3 and the minus 4. You got to factor this. What multiplies to negative 24 and adds up to negative 5 is negative 8 and positive 3. So you get 3 cosine x minus 4, 2 cosine x plus 1, which leaves us with options. Cosine x is 4 over 3. That's impossible. 4/3 is greater than 1. You can't do that. Or cosine x is negative 1/2. That happens at 120, and we want all real values. So we say 120 plus 360k, 240 plus 360k. This one, you got to factor it. You get sine x minus 2, 2 sine x minus 1. So sine of x is 2, which is impossible. Or sine of x is 1/2, which happens at 30 plus 360k, and 150 plus 360k. 3 secant squared equals 4. Secant squared equals 4/3. Well, let's make this a little easier for ourselves. Secant is the reciprocal of cosine, so I'm going to replace this with cosine is 3/4. Remember, they're reciprocals, so they're equal to, I don't know, I just turned over the 4/3. So cosine is plus or minus the square root of 3/4, which is square root 3 over 2. So that happens at 30 plus 360k, at 150 plus 360k, at 210 plus 360k, and at 330 plus 360k. Tangent of tangent times tangent x minus 1 equals 0, already factored. Tangent of x equals 0, tangent of x equals 1, so 0 plus 360k, 180 plus 360k, 45 plus 360k, 225 plus 360k. That's not wrong, and I wouldn't mark it wrong on a quiz, that's totally fine, but in fact tangent has a period of pi, so instead of writing all 4 of these, you can just write 0 plus 180k, which will take care of both of these, and 45 plus 180k, which will take care of both of these. So, but this answer is totally fine. That is that.